Hey class, good afternoon. Hopefully you guys are doing well. Sorry I'm not able to be there, but at this point I'm probably at home with my new baby. When I'm giving these notes, we have not had a baby yet, but by the time you guys take these notes, hopefully I'll be at home with my new baby. So let's get to it. Today, notice we're on lesson 4, which is special parallelograms. It actually goes along with what we're doing on page 312 in the textbook. It's section 6.4. We are skipping lesson 3 just because of time reasons. I chose not to cover that section. But today we're going to talk about special parallelograms, which are those rhombuses and rectangles. Remember what we did back in lesson 1. We talked about how parallelograms can be split up into either a rhombus or a rectangle, and then both of those become, there's a special one called a square, which is really a rectangle and a rhombus. So theorem 6.9 states that each diagonal of a rhombus bisects two angles of that rhombus. So here's a diagonal going from one vertex to the opposite vertex. And what it's going to do, it's going to bisect this angle here, and it's also going to bisect this angle here. And remember, whenever we say bisects, it's going to split into two equal angles. And since it's a parallelogram and it's a rhombus, these opposite angles are going to be congruent. So therefore, this angle is going to be congruent to this angle, which is going to be congruent to this angle and to that angle. All right. Also, these diagonals, if we draw two of them from A to C and then one from B to D, they will always form a 90-degree angle. So the diagonals of a rhombus are perpendicular. All right, so let's use this information to find some other information. So if we have this figure here, and we have a parallelogram or a rhombus, MNPQ, if this angle is 120 degrees, that means the angle across from it is 120 degrees as well. We have to figure out what these angles are. Actually, we're looking for angles 1 and 3 for now, and this is angle 3 up here. Well, how can we do this? Well, as we said earlier, it's going to bisect it based on that theorem up there. So this angle and this angle are going to be the same, because this whole angle and this whole angle are opposite angles and they're congruent to each other. So if they cut them in half, then 1 and 3 have to be the same. So if I'm going to call this x, you can call this one x as well. And now you'll see that we have a little triangle. And what is the degree measure of a triangle? Hopefully all yelled out 180 degrees. So now we can say that 2x plus 120 equals 180. 2x is, I just added x plus x. So now let's subtract off 120. You have 2x equals 60. So x equals 30. So if this is 30, that means measure of angle 2 is also 30. That means measure of angle 4 is also 30. So measure of angle 2, or we should say this, measure of angle 1 is 30 degrees, measure of angle 3 is 30 degrees, measure of angle 2 is 30 degrees, and measure of angle 4 is 30 degrees. And what do you notice about those measures? Well, obviously it's the same as measure of angle 1, and the measure of angle 3. Alright, so now we have another figure. I'm going to scoot this over so you can see the figure. Sorry. Alright, so we have to find the measure of angle 1. Well, we know that this is a rhombus, and we know that these are two diagonals that go across from vertex to vertex. They form 90-degree angles. So if this is 90 degrees, this is 90, that's 90, and that's 90. So we can actually find measure of angle 2 pretty easily. That's going to be 90 degrees. We also know that this diagonal is going to bisect this entire angle. So that means it's going to split these in half. So, or split this whole angle in half. If this part is 66, that means this part is also 66 degrees. So the measure of angle 1 is 66 degrees. And just like the problem before, the opposite angle, the angles were the exact same. So over here, this is 66 degrees, and this is also 66 degrees. So the measure of angle 4 is 66 degrees. Now, there's a couple different ways to find the measure of angle 3. Some of you are going to say, well, I see a triangle. Look at this triangle right here. And if we see a triangle, we know two angle measures, we should be able to find the third. So let's add it up. 66 plus 90 plus x equals 180. 66 plus 90 is 156, plus x equals 180. And if we subtract off 156, x is equal to 24. Well, what if you didn't want to do it that way? What if you wanted to talk about it in terms of the entire figure? Well, remember, all quadrilaterals add up to be 360 degrees. N minus 2 times 180, right? 4 sides minus 2 is 2. 2 times 180 is 360. So let's add up all of these angles and set it equal to 360. So we have 66 plus 66. Well, we're looking for this angle x, which is going to be this angle x, which is also going to be equal to the opposite angles. So I have 2 x's plus 2 more x's, so there's 4 x's total, plus another 66 plus another 66 equal to 360 degrees. You add all these 66's up, you get 264 plus 4x equals 360. If you subtract off 264, you get 4x equals 96. X is also equal to 24. So it doesn't matter how you do the problem. If you treat it as a triangle or if you treat it as the quadrilateral itself, you will be able to find the measure of angle 3 to be 24 degrees. Alright, the next theorem that we're going to talk about is a diagonal of a rectangle. And this is pretty self-explanatory. The diagonal of a rectangle are congruent. So if we go from one corner to the next, is going to be equal to the diagonal of the other corner to the other opposite corner. So in this example, we have GE is congruent to FD. So in this example here, if GE, 6y, and let's make this minus 4. That was a typo. Should be 6y minus 4 equals 2y plus 4. So we subtract off 2y. And I'm going to add 4 just for the sake of saving space. So 4y equals 8. So therefore y equals 2. It does say to find the length of it. So FD is equal to 2 times 2 plus 4, which is 8. Which is obviously going to be the same as GE, because it does ask you to find the lengths of the diagonals. And it should be, or it will be, the same. We got one more problem on the back to do that pertain to the diagonals of the rectangle. And again, we have a slight little typo. Let's make this 5 a 7. So we have 5y minus 9 equals y plus 7. I'm going to subtract y. Let's go ahead and add 9. So we have 4y equals 16. So y equals 4. FD, which is also congruent to GE, is going to be 5 times 4 minus 9, which is going to be 11. Alright, so now we have to figure out, is the parallelogram going to be a rhombus, a rectangle, if we can prove that or not. So based on the theorems that we just really talked about, it says if a diagonal of a parallelogram bisects the two angles, then it's a rhombus. So if we bisect the angle with the diagonal, it's a rhombus. If the diagonals form a 90-degree angle, it's also a rhombus. And then if the diagonals are congruent to each other, then we have the special one called a rectangle. Let's see if we can figure these out. Quadrilateral has congruent diagonals and one angle of 60 degrees. Well, a quadrilateral that has congruent diagonals, this has to be a rectangle. It's the only one that has congruent diagonals. But do rectangles have angle measures of 60 degrees? And hopefully you're all yelling, no, 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 they do not. They don't. Remember, all rectangles are formed with 90 degrees angles. So therefore, this is not possible. That 60 allows us not to be able to figure out what type of parallelogram it is. Alright, what about a quadrilateral that has perpendicular diagonals? So perpendicular diagonals, that tells us it's going to be a rhombus. And it has 4 right angles. So can a rhombus, which has all sides the same, have 4 right angles, and then have diagonals that are perpendicular? And that is absolutely true. So we do have a rhombus, not a rectangle, but this rhombus is a special rectangle, which is going to be actually a square. Alright, now next one, it says a diagonal of a parallelogram bisects 2 angles. So since it's bisecting 2 angles, we're talking about a rhombus. Is it possible to have a parallelogram have 5, 6, 5, and 6 as its sides. So let's just draw a parallelogram. So this would be 5, this would be 6, this would be 5, this would be 6. Can this shape be a rhombus? And hopefully you're all saying, no, not possible. And you're like, why? Sure looks like it can be. The reason why is that a rhombus has to have congruent sides. So a rhombus has congruent sides. So that's why this is not possible. And since it bisects those angles, it can't be a rectangle. So that one's not possible as well. Alright, well, hopefully you enjoyed those notes as well, like you've enjoyed all the rest of them. We do have one more set of notes coming forward in a day or so, and that will be it for the semester. You're going to have a little quiz on all of this material, and then we're going to start reviewing for the final exam. And the final exam will be multiple choice, and it will be on the 25th, if I'm not mistaken. So you still have some time to start preparing and studying. I suggest that you go back through all of your notes and start organizing things and start reviewing things that we have been going over throughout the whole semester. And if you have any questions, please feel free to email me, or you can ask Ms. Trubiano or Mr. Schneider. Hopefully they're going to be popping in once in a while to answer any questions that you guys have. So hopefully you guys are doing well, and I will see you soon. Be good and take care, guys.